Hey, it's Warner, and let's go ahead and take a look at this problem. So what we're trying to do is find out how much friction there is between boxes B and C. And we know that the coefficient of static friction between B and C is 0.6. And we know that the system starts at rest. So to find how much friction there is between B and C, the very first step we need to do is set up a net force equation for the entire system. So to do that, notice I already have the free body diagrams that I need for box A, box E, just the left and right for box B and C, and then the up and down for box D. So if I do the net force is equal to the total mass of the system times acceleration, I'm going to start with the weight of A and the weight of E, and those together are going to go down. So that's in the positive direction. From there, I'm going to move up to the tension, and the tension here is minus T1. And then if I go to box B, you'll notice that T1 is to the left, and that's the direction of motion, or the direction of acceleration, and so I'm going to add that T1. Those two T's disappear because they're equal and opposite. At that point, I have T2 going to the right, which is negative, and then I have T2 up on this box, which I see is positive. I also have MdG going in the negative direction, and all that's equal to MTA. Notice I didn't do anything with the force of static friction on box C because it's outside of this line that we have that's connecting the other boxes. I go ahead and I added the 12 plus 2 and got 14, took that times gravity, and then subtracted the mass of D, which is 4, times gravity, which is 10, and then that's equal to the total mass of this whole thing, including box C, and that's 23 kilograms times A. Go ahead, do the math, and you'll find out that the system accelerates at a rate of 4.35 meters per second squared. Step 2 is to find the forces on box C, and I see that the only force I really have is just the force of friction trying to pull it to the left from box B. So that's equal to mu, which is 0.6, times the normal force on C, which is really just its mass times gravity. If I go ahead and do that, I found out that the maximum force of static friction is on C is 12 newtons. Now I'm going to find out when it accelerates what that static friction would be, because remember, static friction increases as you increase the acceleration. So I remember my acceleration is 4.35, and I know that the net force is equal to mass of C times that 4.35 acceleration. The only force is to the left, and that's positive. That's equal to mc times its acceleration. And so now I just plug in 2 times 4.35, and I see that it's only 8.7 when the system is moving. Because this is less than the maximum static friction before it turns into kinetic, I know that that friction is static, and it's only 8.7. Remember, this is just the maximum friction, and they want to know how much friction there is with the acceleration of 4.35. So that's what you see here. For the next part, they want to know how hard does box E push on box A. For box A, we know the net force is equal to the mass of A times A. And so I'm going to do mg down, which is positive. And I also have a normal force from E on A. And so I'm going to draw that in, and that would be a normal force right here. So it's actually right there. So there's a normal force from E on A. That's also pointing in that same direction. And then I subtract from that T1, and I'm going to then say that's equal to the mass of A times its acceleration. So at this point, I need to find out what T1 is, but I can do that easily because I can say the net force for the system of A and E block together is the mass of A and E block times the acceleration of A and E block, which we already know. So I went ahead and added the 12 plus the 2, got 14, gravity is 10. Subtract the tension that we don't know. So remember, we don't know what T1 is, and that's what we're going to have to try to find. So that's equal to the mass of A plus E times A. That is 14 times 4.35, and now I can solve for the tension in that line that is connecting those two blocks. So remember, I've got E here, I've got A here, so down would be the mass of A plus the mass of E times gravity, and up would be the tension. So I found that tension to be 79.1. I'm going to go back now to just box A, and I want to see what's the normal force between the two. So we had this number, we didn't know what T1 was, so we went here, found it, now we're going to plug it in, and that's equal to the mass of A times its acceleration. At that point, you just solve for the normal force between A and E, and we find out that that is about 11.3 newtons. And that is it.